This is SpaceTime, Series 28, Episode 89, for broadcast on the 25th of July, 2025. Coming up on SpaceTime, the new interstellar object 3I Atlas may be older than our solar system, unravelling the mysteries of a rare pulsar, and the Axiom 4 crew safely return to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers say the mystery interstellar object discovered earlier this month is likely to be the oldest comet ever seen, possibly even predating the solar system by more than 3 billion years. The water ice-rich visitor named 3I Atlas is only the third known object from beyond our solar system ever spotted in our cosmic neighbourhood, and it's the first to reach us from a completely different region of our Milky Way galaxy. A new study by Matthew Hopkins from Oxford University speculates that 3I Atlas could be more than 7 billion years old, and may be the most remarkable interstellar visitor yet. Unlike the two previous objects to enter our solar system from elsewhere in the cosmos, 3I Atlas appears to be travelling on a very steep path through the galaxy, with a trajectory that suggests that it probably originated from the Milky Way's thick disk. Now that's a population of ancient stars orbiting above and below the thin plane where our Sun and most other stars in the galaxy reside. Hopkins says all non-interstellar comets, such as Halley's Comet, formed with our solar system, and so are at most 4.5 billion years old. But interstellar visitors have the potential to be much older than that. According to Hopkins, his statistical calculations suggest that 3I Atlas is very likely to be the oldest comet we've ever seen. The object was first detected back on July the 1st, using NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS survey telescope in Chile. At the time, it was some 670 million kilometres from the Sun. Hopkins' research predicts that because 3I Atlas formed around an old thick disk star, it's likely to be rich in water ices. If so, it's from a part of the galaxy astronomers have never seen up close before. Now, as it approaches the Sun, sunlight will heat 3I Atlas's surface, triggering cometary activity, the outgassing of vapour and dust, and creating a glowing coma and tail. Now, early observations already suggest that the comet's active, possibly much larger than either of its two interstellar predecessors, 1I Oumuamua, which was spotted back in 2017, and 2I Borisov, which was seen in 2019. Now, if confirmed, this could have implications for how many similar objects future telescopes such as the Vera C. Rubin Observatory are likely to detect. It may also provide clues about the role that ancient interstellar comets play in seeding stars and planetary formation across the galaxy. Already, some of the biggest telescopes on the planet are observing this new interstellar object, and numerous astronomical teams are studying this interstellar visitor and writing papers based on their observations. As well as the 4 Atlas telescopes, 2 in Hawaii, 1 in Chile and the other in South Africa, the European Southern Observatory's Very Large Telescope, the VLT, the Southern Astrophysical Research Telescope, and the Gemini South Observatory are also monitoring this object closely. Though data is pouring in about the discovery, it's still a long way away from the Earth. That's leaving a lot of unanswered questions. So far, astronomers have determined that 3I Atlas is moving really quickly, on a hyperbolic velocity of just under 60 kilometres per second relative to the Sun. Now that compares to 26 kilometres per second for Oumuamua and 32 kilometres per second for Borisov. The diameter of 3I Atlas is currently estimated to be as much as 10 kilometres wide, which would make it 100 times larger than Oumuamua, 10 times larger than Borisov. It's on an orbital path shaped like a boomerang or hyperbola, and exceptionally eccentric, where eccentricity describes how much an object's orbital path is stretched out. An eccentricity of 0 is a perfect circular orbit, while an eccentricity of 0.999 is a very stretched out ellipse. Any object with an eccentricity above 1 is on an orbit that doesn't loop back around the Sun, implying that it comes from and will return to interstellar space. And 3I Atlas has an eccentricity of 6.2, which is highly hyperbolic and ensures its classification as an interstellar object. In comparison, Oumuamua had an eccentricity of about 1.2, while Borisov was about 3.6. Right now, 3I Atlas is within Jupiter's orbit around the Sun, at a distance of about 465 million kilometres from Earth, and still around 600 million kilometres from the Sun. The closest it'll come to Earth is about 270 million kilometres, That'll be on December the 19th. It'll reach its closest approach to the Sun, perihelion, around October the 30th at a distance of 210 million kilometres. That's just inside the orbit of Mars. Now, during this close approach, it'll be travelling at around 25,000 kilometres per hour. Now, the comet is extremely bright. That'll provide clues about its composition as it degasses more volatiles into space as it heats up as it gets closer to the Sun. And while it's on a path that will leave our solar system never to return, scientists will be able to study it for several months before it departs. Both the Webb and Hubble space telescopes will be focused on the comet, revealing more information about its size, composition, spin, and how it reacts to being heated by the Sun over the next few months. Right now, it's still just a fuzzy blob, but eventually, astronomers should be able to determine the composition of the gas and dust shedding off the comet. They'll also be looking for changes in its brightness, because that will tell astronomers about the evolution of the coma, and they'll be monitoring for sudden outburst events, during which time the object gets much brighter. That'll provide information about its structure and composition. For sky watchers keen to get a glimpse of 3i Atlas, well, it should be visible through a reasonably sized amateur telescope later this year and early next. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, unravelling the mysteries of a rare pulsar. And the Axiom Space AX4 crew have returned splashing down in the North Pacific Ocean off the southern coast of California. All that and more still to come on SpaceTime. Astronomers have discovered new evidence explaining how pulsing remnants of an exploded star are interacting with surrounding matter in the deep cosmos. The new observations, reported in the astrophysical journal Letters, are based on data from NASA's Imaging X-ray Telemetry Explorer, or XP, spacecraft. Astronomers have been examining a mysterious cosmic duo known as PSRJ 1023 plus 0038. The system is composed of a rapidly spinning neutron star, or pulsar, which is pulling material off a nearby lower mass stellar companion. This material has created an accretion disk around the neutron star. Being a pulsar, it's creating powerful twin beams of light and energy from its opposing magnetic poles as it rotates, spinning like a lighthouse beacon in the night. This system is rare and valuable to study because the pulsar transitions clearly between its active state, in which it feeds off its binary companion, and a more dormant state when it emits pulsations in radio waves. And that makes it what astronomers call a transitional millisecond pulsar. The study's lead author, Maria Cristina Baglio from the Italian National Institute of Astrophysics, says transitional millisecond pulsars are cosmic laboratories, helping astronomers understand how neutron stars evolve in binary systems. The big question for scientists about this pulsar system is where do the X-rays originate? And the answer will inform broader theories about particle acceleration, accretion physics, and the environment surrounding neutron stars right across the universe. The authors found that surprisingly the X-ray source was the pulsar wind, a chaotic stream of gases, shock waves, magnetic fields, and particles accelerated to near the speed of light that hits the accretion disk. To determine this, astronomers needed to measure the angular polarization in both X-ray and optical light. Polarization is a measure of how organized light waves are. So they looked at X-ray polarization using XP, the only telescope capable of making this measurement in space. They then compared that to optical polarization measurements using the European Southern Observatory's Very Large Telescope in Chile. XP was launched back in December 2021. Over the years, it's made many observations of pulsars, but this is the first system of this kind it's ever explored. The authors also used the NISA, Neutron Star Interior Composition Explorer instrument aboard the International Space Station, as well as the Swift Space Telescope, to provide valuable additional observations of the system in high-energy light. And the Very Large Array Radio Telescope in New Mexico also contributed data to the project. Now, as a result of all this data, the authors found the same angular polarization right across all the different wavelengths. And that finding is compelling evidence that a single coherent physical mechanism underpins the light being observed. It also challenges the conventional wisdom about neutron star emissions of radiation in binary systems. See, previous models had indicated that X-rays probably came out of the accretion disk, but this new study shows that they actually originate with the pulsar wind. XP's already observed many isolated pulsars, always finding that the pulsar wind powers the X-rays. So these new observations further confirm that the pulsar wind powers most of the energy erupting out of these systems. This report from NASA TV.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, study X-rays from some of the most extreme objects in the universe, like black holes, in a new way, at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPE will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into supernovae, the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPE will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.
This is SpaceTime. Still to come, Axiom Space's AX-4 crew returned to Earth safely, and later in the science report, a new study shows that high body mass index from early childhood and adolescence is linked to faster biological aging. All that and more still to come on SpaceTime. Axiom Space's AX-4 crew have returned safely to Earth, splashing down in the North Pacific Ocean off the Southern Californian coastline. The privately funded mission spent almost 3 weeks in orbit, undertaking dozens of experiments aboard the International Space Station. The mission had launched from the Kennedy Space Center aboard a Falcon 9 rocket, arriving on station a day later. The flight aboard SpaceX's newest Dragon capsule named Grace included American, Indian, Polish and Hungarian crew members. SpaceX now has 5 human-rated Dragon spacecraft: Endeavour, Resilience, Endurance, Freedom and Grace. In total, they've flown some 18 missions, carrying 70 humans into orbit and back. This flight was Axiom's 4th mission to the orbiting outpost since 2022, and it was part of NASA's ongoing efforts to open up space to more commercial activities. Axiom's one of several companies now developing their own private space stations, which are intended to replace the current International Space Station, which will be deorbited by NASA in 2030 after more than 30 years of operation. The return of Grace and the Axiom Space AX-4 crew have provided room on the orbiting outpost for NASA's upcoming Crew 11 mission, which at this stage is slated for launch on July the 31st. That'll use the Dragon spacecraft Endeavour, launching off Pad 39A at the Kennedy Space Center for a record 6th time. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that having a higher body mass index from early childhood and adolescence is linked to faster biological aging. The findings, reported in the Journal of the American Medical Association, are based on a Chilean study showing that kids with long-term obesity displayed biological signs of aging that suggested they were between 2.23 years and 4.88 years older than they actually were by the time they reached the age of 30. An accompanying editorial says that this new awareness of the effects of obesity in accelerating the aging process represents an additional element for educational campaigns that aim to address this global epidemic. Scientists have sequenced proteins extracted from the remains of a 23-million-year-old extinct rhino fossil. The findings, reported in the journal Nature, are among the most ancient proteins ever sequenced, and they're helping to rewrite the rhinoceros family tree. The sample of enamel has allowed researchers to partially sequence 7 proteins, and it's allowed scientists to place the species in a new branch of the rhinoceros family tree, which splits off between 41 and 25 million years ago. The findings suggest that proteins can survive better than researchers thought, and it raises the possibility of gleaning molecular insights about evolutionary relationships, biological sex and diet from even older animals, and maybe even dinosaurs. A new study has been looking at which over-the-counter medicines are good at treating the symptoms of depression. The findings, reported in the journal Frontiers in Pharmacology, investigated the existing evidence for depression treatments which you can find at your local supermarket. The authors found 64 different products tested in some 209 clinical trials, although the levels of evidence differed widely between them. The products that had been treated the most were the best known. These included omega-3 in 39 trials, St. John's wort in 38 trials, prebiotics in 18, saffron also in 18 trials, and vitamin D in 14 trials. The evidence was strongest for St. John's wort and saffron, which often showed effects similar to those of prescription antidepressants. The trials also suggested that probiotics and vitamin D are also more likely to reduce depressive symptoms compared to placebo treatments. However, the majority of trials looking at omega-3 fatty acids found it did not affect depression at all. They also identified 18 products which demonstrated emerging evidence for treatment of depression, the most promising of which was folic acid, followed by lavender, zinc, tryptophan, rhodiola, and lemon balm. In another clear case of stating the bleeding obvious, a Brazilian psychic who likes to describe himself as the living Nostradamus has issued a chilling warning about the rise of machines, specifically the growing threat posed by artificial intelligence. But as Tim Bendham from Australian Skeptics points out, the so-called living Nostradamus says humanity may be able to save itself with the help of magic crystals.
The living Nostradamus is a psychic from Brazil named Athos Salome, who is, if he's referred to as the living Nostradamus, that's a shame because Nostradamus is full of rubbish, and his predictions are sort of dodgy at best and reinterpreted and actually fabricated at worst. Anyway, so this person has predicted a chilling warning about AI. Whoopie-doo. That's probably not that hard, saying that machines are already thinking for themselves and are able to adapt and learn on their own without asking permission. The computer sort of comes alive and takes over control. it's a conscious entity, if you like.
A lot of people say that's already happened. I mean, we know that AI now has the ability to talk with other AIs and develop their own language. They've proven that. And we also know that when you instruct an AI to kill itself, it won't kill itself. It'll simply hide in another system or change its name and identity, but it will stay alive.
Yes, I know. AI can be a worry, and so therefore this living Nostradamus predicting that there'll be problems with AI, it's not exactly unique. I'm sure there's a lot of other people predicting the same thing, seriously or not, with or without psychic powers. He does add that...
Most computer scientists predict AI will become the dominant force on our planet within the next 10 years, so yeah.
Okay, 10 years. Okay.
That's a given. That's a given.
But this particular person, the living Nostradamus, Mr. Salome, adds that vibrational therapists and bioenergy experts are detecting a new phenomenon affecting the subtle field of environments, and he believes in the invisible effect, which is all gobbledygook. It's nonsense words thrown together, which makes it sound sort of impressive. What he does suggest is when it comes to energy, you should keep crystals such as black tourmaline, amethyst, and blue kyanite nearby. So to protect yourself against the end of the world, you have a few crystals beside you.
I think it's all a little bit like predicting an earthquake in San Francisco. You know it's going to happen. It's just a question of when.
That's right.
And this is the same sort of thing because the threat of AI is real. That's not something that sci-fi writers are making up. It's an accurate prediction of what's going to happen in the future.
It's very interesting, actually. We had some recent psychic predictions that came out just not like a week ago or something. Someone saying there'll be trouble on the India-Pakistan border. Whoops. I think you're reading the newspapers, to try and get this sort of stuff. Or there might be problems between China and Taiwan. Yeah?
Russia
or the Middle
and
East.
Ukraine may have more problems.
The
Middle East, yes, exactly.
I know, and that's all of those they actually mentioned. I think, well, this is uncanny. How could you have predicted these things? They've been happening for a while. So the psychic predictions of doom and gloom are always with us. They're spread very quickly thanks to modern media, and no one follows up apart from the skeptics who follow up all the time and are real party peoples when they point out it didn't happen.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.